Okay, so yesterday we did adding and subtracting, fractions and mixed numbers, and today we're going to do multiplying and dividing. So the good news is this is generally easier than adding and subtracting. And the reason is that you don't have to find a common denominator. When you're adding and subtracting fractions, you must have common denominators. In multiplying and dividing, you do not need one. In fact, and I cannot say this enough, do not try to find one. Some people just automatically try to find common denominators no matter what. And really, it's not technically going to be wrong. Because if you're making equivalent fractions, they have the same value, you would end up with the same answer anyway. What happens though is that you just make your numbers so much bigger and then you add in so many more steps, and with every step is a place to make a mistake. So just don't worry about common denominators. You still have to change all mixed numbers to improper fractions though. In fact, with adding and subtracting, it was suggested and recommended, but with multiplying and dividing, you must turn all mixed numbers into improper fractions. Okay. So, when you're multiplying, really what makes your life a lot easier is if you can get all the numbers in the problem as small as possible before you even start any multiplying. So your first step should be to see if you can reduce your fractions at all before you multiply. Once you do that, you just multiply your numerators, you multiply your denominators, and you always make sure your answer is in lowest terms. If you've done step one well, then your answer will be in lowest terms and you won't have to do anything else. If you skip this step or only simplify partially, you'll still have to do a little bit of reducing at the end. So, sometimes people aren't that comfortable with cross-canceling, that's what we call it, kind of simplifying within the problem, really because they're not very good with their math facts. So they're not very good with recognizing common factors. So if I had this problem, 4/25 times 15/44, there's really a long way to do it and a short way to do it. The short way is down here. I looked at my numbers and tried to find if there's any common factors in any combination of numerator and denominator. So I looked here, 4 and 44 have a common factor of 4. So I'm going to divide both of those numbers by the common factor. 4 divided by 4 is 1. 44 divided by 4 is 11. 15 and 25 had a common factor of 5. So I divide by that common factor. 15 divided by 5 is 3, and 25 divided by 5 is 5. I did all of this cross-canceling and got my numbers as small as I could within the problem. Then I multiplied numerators, 1 times 3 is 3, and multiplied denominators. 5 times 11 is 55, and that is in lowest terms. I could go the long way, which is no cross-canceling, no finding common factors beforehand, and just multiplying the numerators and denominators. So 4 times 15 is 60. 25 times 44 is 1100, which I didn't know until I did this math over here. And I'm usually pretty good with multiplication. Of course, I'm going to make a fact error somewhere along the line in one problem or another, but I do understand the process. So I had to do some multiplication. I just moved over here because I ran out of room. So 60 over 1100, I recognize because they both ended in 0 that there is a common factor of 10. So I at least started there. 60 divided by 10 is 6. And 1100 divided by 10 is 110. Again, when you're dividing by 10, you just kind of knock off the last 0. I recognize that those could still be simplified because they were both even. So I know that they had a factor of 2. 6 divided by 2 is 3, and 110 divided by 2 is 55. So again, you can see I got the same answer either way. This just involved a few more steps, a few more complex processes, so there's just more places to make a mistake. So if you can reduce within the problem, you really should. So just to go through a few other examples. 4/9 times 6/15. First thing I'm going to do is look for any common factors in some combination of numerator and denominator. So 4 and 15 don't have any common factors. 6 and 9 do. So I'm going to start there. The common factor of 6 and 9 is 3. So I'm going to divide by that common factor. 6 divided by 3 is 2, and 9 divided by 3 is 3. I'm looking at all of my numerators and denominators right now. No more common factors. So now I just multiply. 4 times 2 is 8. 3 times 15 is 45. And because I did all my cross canceling, that's in lowest terms. Then I have 3 over 16 times 24 over 27. Going to start looking for common factors. So the first one that's jumping out at me is 3 and 27. The greatest common factor is 3. So 3 divided by 3 is 1. 27 divided by 3 is 9. Then I'm going to look here, 24 and 16. The greatest common factor there is 8. Again, there's 2, there's 4, but if I find the greatest common factor, I can do all my simplifying in one step. So I'm going to divide both by 8. 16 divided by 8 is 2, and 24 divided by 8 is 3. Then I'm going to multiply. 1 times 3 is 3. 2 times 9 is 18. And then I'm going to go, that's actually not in lowest terms. I wonder what happened. Well, what happened right here was when I did all my cross canceling on the diagonal, I ended up with a fraction here that actually wasn't simplified. So I could have done more cross canceling right here, or I could just reduce it right here. So my common factor is 3. 3 divided by 3 is 1. 18 divided by 3 is 6. And if I would have cross canceled right here, this 3 would have canceled out to a 1, and this 9 would have canceled out to a 3, and I still would have had 1/6. And that is my final answer there. Now, as I said earlier, when we added and subtracted mixed numbers, changing them to improper fractions was highly recommended because you avoid regrouping. Most people make a lot of mistakes in the regrouping part. But with multiplying and dividing mixed numbers, you have to turn them into improper fractions. You cannot leave them as mixed numbers. And you don't just multiply the fractions together, multiply the whole numbers together, and end up with an answer. That doesn't work. So the first thing I'm going to do is change these mixed numbers to improper fractions. So 3 times 2 is 6, and 6 plus 1 is 7. Keep the denominator. 1 times 7 is 12. 1 times 7 is 7, and 7 plus 5 is 12. Now I'm going to see if I can cross cancel anything because I want to reduce within my problem. Well, 7 and 7, that's just going to cross out. They're going to totally cancel out. 2 and 12, my common factor is 2. So 2 divided by 2 is 1. 12 divided by 2 is 6. I multiply my numerator, 6. I multiply my denominator, it would be 1. I could write it 6 over 1. That's not going to be wrong, but I could just leave it as a 6. And then 10 times 17 over 90. I am going to put this 10 over 1 just because it helps me look at it in a little bit more balanced way, and sometimes it helps me see something I might have missed otherwise. So I'm still going to see if I can cross cancel. 10 and 90, I know have a common factor of 10. So 10 divided by 10 is 1. 90 divided by 10 is 9. Multiply my numerators. 1 times 17 is 17. And my denominators. 1 times 9 is 9. And that is in lowest terms. So again, with multiplying fractions and mixed numbers, the best thing you could do is see if you can cross cancel within the problem by dividing by common factors. If you are not very confident with your math facts, then you still can just multiply numerators and denominators. You'll just have more simplifying to do at the end. You must change mixed numbers into improper fractions in order for it to work. And don't do any cross-canceling whatsoever until you've done that. You can't try to cross-cancel things when they still are in mixed number form. And if you do have a whole number, no matter what the operation, remember, every whole number can be a fraction if you just put it over 1. So that is multiplying fractions. Let's get to dividing. Okay. So dividing just has a rule that is called multiply by the reciprocal. Basically, that just means change the division to multiplication and then flip the second fraction. Once you do that, you are following all the same steps as multiplication. And again, with division, you have to change all mixed numbers to improper fractions. Only flip the second fraction. If you flip the first fraction, it won't be right. If you flip both of them, it won't be right. You only flip the second. You cannot do any cross-canceling until you have done that. You can only cross-cancel in multiplication. Don't try to cross-cancel here. Again, everything is pretty much the same as multiplication after that. So when I look at this, my eye might catch, ooh, these nice 7s and this 2 and this 12 and think I'm just going to cross-cancel right now, but I can't. I have to change this to multiplication and flip the second fraction before I can do any cross-canceling. So this stays, division changes to multiplication, and I flip this second fraction. So instead of 12 over 7, it's 7 over 12. Now is where I could look to see if I can cross-cancel. Well, 7 and 12 don't have any factors, and 7 and 2 don't have any common factors. So I cannot cross-cancel. 7 times 7 is 49, and 2 times 12 is 24. And that is in lowest terms because there were no common factors in this problem. And I can just leave it like that. Here I have some mixed numbers, so I have to change them to improper fractions before I can do anything. 1 times 14 is 14. 14 plus 13 is 27. I'm still going to keep this division for now because I don't want to try to do too many things in one step. That's where I'm going to make a mistake. 4 times 2 is 8, plus 1 is 9. So I changed my mixed numbers to improper fractions. Now I have to do the old flip and switch. So 27 over 14 times flipping this second fraction, 2 over 9. Now that it is a multiplication problem, I can look and see if I can cross-cancel anywhere. So 2 and 14 have a common factor of 2. 2 divided by 2 is 1. 14 divided by 2 is 7. 27 and 9 also have a common factor of 9. So if my common factor is 9, 9 divided by 9 is 1. 27 divided by 9 is 3. Now I can multiply. 3 times 1 is 3. 7 times 1 is 7. And that is in lowest terms because I already did all of my cross-canceling. I have to change this mixed number to an improper fraction. 3 times 4 is 12. 12 plus 3 is 15. I'm still going to leave this for now because I only want to do one step at a time. And remember, in order to keep things straight, sometimes the best thing to do is write your whole numbers over 1. So now I'm going to do the flip and switch. Keep my first fraction, switch division to multiplication, and flip the second fraction. Now I'm going to look for common factors. Well, 1 can't be reduced at all, so that's not going to do anything for me. 15 and 4 don't have any common factors, but 15 and 6 do. They both have the factor of 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. No more common factors anywhere. 5 times 1 is 5. 4 times 2 is 8. And that is my answer in lowest terms. And then the last one. Again, I have to change all mixed numbers to improper fractions. So 6 divided by 2 times 3 is 6. 6 plus 1 is 7. I'm going to do the flip and switch. So 6 times, then I'm flipping this fraction, 3 over 7. And I'm going to put that over 1 so that I could keep track of everything. Looking for common factors, I don't have any. 1 is as low as it's going to go. 6 and 7 don't have any common factors. 3 and 7 don't. So now it's just multiplication. 6 times 3 is 18. 1 times 7 is 7. And that's in lowest terms. So again, with multiplication, as with multiplication and division, make sure you're switching all of your mixed numbers over into improper fractions. When you are dividing, make sure you are changing division to multiplication and then flipping the second fraction. That's called multiplying by the reciprocal. Once you have a multiplication problem, you can start cross-canceling, looking for common factors inside the problem, so that when you do multiply, your numbers are smaller and hopefully your answer is already in lowest terms. Again, please ask questions as you have them. Bye.